Well, hello YouTube, Louie here. I saw an article recently from Coin World talking about the Green Revolution, and they referenced, and silver's a part in it. They referenced this report prepared for the Silver Institute called "The Role of Silver in the Green Revolution," published July 2018, and I will put a link to it down below so you can read it yourself. I thought I would do some excerpts. It's quite a long report, but let's see what we find interesting in here and whether there is any guidance as to whether silver is actually a valuable metal or just a pretty rock. Let's see, let's go on to the table of contents. Executive summary. Okay, we have got solar, nuclear, transportation, and conclusions. Okay, what shall we hit first? Well, solar, of course. Let's go to 1.1. Oh, well, I guess we could start with the executive summary. Huh? Okay, that wouldn't hurt. With its unique conductive and chemical properties, silver is an important industrial metal with integral roles in many electrical and electronic applications. This study is intended to inform the Silver Institute. Okay, we're going to skip that. Key findings. The cost of installing and providing solar photovoltaic has fallen rapidly relatively to other electrical energy sources over the past 2 decades, even with factoring out the effects of solar subsidies and taxes penalties on non-renewable outsourcing. On non-renewable energy sources. These trends are expected to continue over the medium term, leading to an ever-increasing share in renewable energy generation and investment, led by macro and public policy. Solar energy uptake will grow most significantly in developing regions during the next decade, led by major policy-driven investments in domestic solar infrastructure within China and India. So enormous capability in China and India for solar. Solar energy uptake is expected to continue growing strongly within the United States, despite some short-term uncertainty associated with recent tariffs on solar PV imports. Okay, so tariffs are a problem. Although solar power will account for a growing share of global electricity generation, the amount of silver used per photovoltaic cell is expected to continue to decline. So they will use less silver in every panel. Thrifting, which is widely utilized across the full metal spectrum, has already brought the average silver loadings per generated kilowatt hour down to 28 grams in 2017. So about an ounce of silver in every average silver loading. Let's see, average silver loading. I'm not sure if average silver loading is one panel or not. And dual printing process, reductions in wafer thickness, and finger width, and to lesser extent replacement of silver with other metals like copper. CRU expects silver loadings in solar PV to continue declining through 2030, albeit at a slower pace. Moreover, it is important to note that silver's unique conductive properties ensure that substitute materials will not be able to match it in terms of energy output per panel. As a result, the pace of silver thrifting is expected to slow. In the transportation sector, okay, so here we have moved on. So to sum up, solar panels, incredible increase in the use of solar panels in India and China. Why not in the USA? Not sure. Probably because we meddled in it in regulatory ways, and probably because the utility companies are blocking it at every step, charging incredible fees to tie into grids and so forth. But on to transportation. In the transportation sector, spurred on by overwhelming policy support, as well as falling cost and greater understanding of the benefits of electric vehicles, new energy vehicles, NEVs, such as battery electric vehicles, yes, I drive one, BEVs, and plug-in hybrids, PHEVs, will account for an ever-increasing portion of global vehicle sales. Based on our electric vehicle model, CRU estimates that battery vehicles may collectively account for as much as 17% of global car sales, while hybrids account for an additional 20% by 2030. So, wow, how sad for us if we can only get to 17% by 2030. It is a superior form of motivation for everything but the most commercial of applications, and it's crazy that we can't move over more quickly than that. The combustion engine will fall victim to the electric vehicle. It is guaranteed that it is a superior form of transportation, and it is a cheaper form of transportation, and the fuel can be free, all right, and without environmental impact. So how can you beat that? How can you beat that? Over time, this will increase the use of EVs and silver in the batteries, and it will decrease the use of combustion engines. This is partly why I'm bearish on platinum and palladium, because it is linked into the combustion engine vehicle market, which will be declining, and EVs will be growing. Okay, the incremental growth in silver loadings with new energy vehicles will have a meaningful impact on future demand for silver for the automotive segment. Within vehicles, silver is primarily used in electrical contacts, which connect electrical components with one another. The automotive battery market remains a commercially untapped opportunity for silver zinc batteries. That's interesting. Due to cost pressures, however, current trends indicate that automakers and their suppliers will continue to invest in lithium-ion technology with nominal investments in silver-bearing battery materials. Okay, so no silver batteries. The value proposition of wireless inductive charging ports and stations will increase substantially if the successful development and mainstream adoption of the autonomous vehicles succeeds. Autonomous vehicles. At the moment, inductive charging for the transportation sector is gaining traction. I believe that's where you drive over a panel and your energy is transferred through the air into your battery with no plugging. CRU expects the adoption of inductive charging stations by the household market to provide meaningful growth. Okay, even so, the technology behind inductive power transfer has come forward in leaps and bounds. This is reflected in the newfound commercialization, with inductive chargers boasting enough technological advancement and consumer convenience to generate sales despite their considerable premium. In total, CRF estimates the demand for silver in the three key green applications, so that was solar panels, that was cars, and what was the third one, guys? Hold on. I think the third category is the conductive transfer of electricity, this transfer through the air, I believe that is. Let's see, CRF estimates that demand for silver in the three key green applications will be in the range of 110 to 140 million ounces each year from 2018 to 2030, with growth in both automotive, yes, solar, absolutely, and nuclear. We didn't touch on nuclear. Smaller but nonetheless positive benefit. Okay, interesting. This is more about inductive coupled power transfer. ICPT works by passing a current through a coiled wire, creating an electromagnetic field that in turn induces a current into another coil. The electrical intensity of the field can be enhanced by using copper wire as the transmitting coil, while silver plating the receiving coil can reduce resistance and so further improve the efficiency of the transfer. Research into the technology's use in wireless charging was first undertaken in earnest in 2006, although working models had been created before. This technology is therefore already commercially available and increasingly common, especially for the smaller scale application of high-end mobile phone chargers. So I think we've all seen those where you set your phone on a little plate and it charges inductively. For electric vehicles, however, the technology is still rather niche, with commercially available options for domestic wireless chargers only offered by third parties, such as plugless power, although major car manufacturers such as Kia and BMW have tested prototypes. I believe they have these in Japan. Although there are some problems associated with scaling inductive charges to the level needed for BEVs, electric vehicles, such as loss of efficiency and the need to precisely align the transmitting coils and receiving coils, these concerns have greatly reduced as the technology matures. Efficiencies have improved from 40% in 2007 to 90% in 2016, and a series parallel configuration on the receiving coil has been shown to charge with less precise alignments that would be typical in actual use. Current charging infrastructure can be broken down by power rating into 3 tiers, as shown in Table 1. Okay, we're going to move on to the table really quickly. All right, well, I'm not going to read you that, but these are the charging stations where you drive your electric vehicle over a plate of some kind, and apparently you have to align it somewhat carefully, and then the charge will come inductively from the floor up into the vehicle. And God help any small animals that get in between, huh? No, I don't know what happens if something comes in between. Let's see. Okay, we're going to skip over that. Hold on one second. All right, well, I think we're at the conclusion of this. I'll read the last paragraph. As this report demonstrates, silver has played and will continue to play an integral role in the future viability of green energy generation and mobility. Although thrifting in solar photovoltaic cells manufacturing may present headwinds for industrial silver demand in renewable generation, the potential for greater silver consumption in the rapidly growing electric vehicle market offers new market opportunities for industrial use. In particular, the growing need for power-efficient, high-voltage wiring harnesses in battery electric vehicles and a gradually rising interest in wireless charging technology and infrastructure present significant potential for silver consumption. Ultimately, as the world increasingly transitions from an energy market dominated by non-renewable combustibles to one powered by cleaner electricity, silver's unique electrical and mechanical properties will broaden the precious metal's already wide range of green technology and applications. All right, so author Alex Lauran, Ibram Yücel, and I will put the link to this report if you'd like to dig into it more carefully. Clearly there's some interesting things there, the positives being the increasing use of electric vehicles of all forms, increasing use of conducting energy from one part to another wirelessly. And in the nuclear industry, offset somewhat by thrifting, which is getting more, for your silver ounce, obviously. But that's where the future is going. I believe I read previously that we are at peak capacity in silver production, and it is really you and I that are creating the lull in silver right now. Investor demand has dropped significantly. The last report I read was by 50% among stackers and collectors and investors, while the SLV, the SLV, the ETF for silver, continues to grow and stay strong. The actual physical metal collecting has dropped considerably. So we've got the backdrop here for continued need and use of solar. And whenever sentiment changes, if it does, that should really push us over the edge. But you and I are really in control of that. And if you think it's cheap, go buy some. If you think it's not, wait a little bit longer. What are your thoughts about the increasing role of silver in green technology? And specifically, I think in photovoltaic cells, which are kind of a no-brainer if you live in a sunny area.